Hello learners, welcome to your favorite e-learning platform Pathshala. I'm Savita Chauhan, your mathematics mentor. Let's just start today a new chapter called as the area of parallelograms and the triangle. So let's just start this chapter. But before that, in the previous classes, we already have learned about the study of geometry, which is actually originated with the measurement of the earth or precisely the lands in the process of recasting the boundaries of the field and dividing them into the appropriate parts. For an instance, if I'm just talking about a farmer Mahiti, actually the farmer Mahiti has a triangular field. He has a triangular field and he just wanted to divide the equal portion of this triangular field to his two daughters and one son. So in order to divide this triangular field into an equal portions, he just divided it into such a formation that all the parts of this triangular field are actually is equal to each other. What does it mean? I am just saying that all the areas of these three parts are actually is equal to each other, and he did this division without any actual calculation. So do you think so, or do you figure it that all the areas of this particular triangular field or the portion of this triangular field are equal in area or not? So for this we definitely need to know about the formulas that are related with such kind of the plane figures. So we already are aware about the formulas that are related with this particular triangular field, means the area of the triangular or the area of the triangle, and many other more formulas that are related with this particular concept. Now let us suppose if I am just moving on further and talking about an important concept which is all related with such kind of the plane figure. So let us suppose if I'm just talking about the planar region. What is a planar region? So a planar region is actually a part of the plane which is enclosed by a simple closed figure. That is nothing but called as a planar region. For an instance, I'm talking about the triangular field of Mahiti. That particular figure was actually enclosing an area within it, and that particular area is nothing but called as the planar region. So always remember, whenever we are just talking about the part of a plane which is enclosed by a simple closed figure, it is nothing but called as a planar region. Furthermore, the magnitude or the measure of this planar region is called as its area. It is nothing but called as its area. So as we were talking about the Mahiti's triangular field, and he divided it into the three equal portions such that the area of each portion is equal to each other, we are actually talking about such kind of the planar regions. Furthermore, always remember, whenever we are talking about the area, we know that area do have specific units. For an instance, I'm talking about the area of the triangle and it is nothing but 25. So we always write the area as nothing but 25 centimeter square. Meter square means the units that are related with the area, that is meter square, centimeter square, and so goes on. So let us suppose if after the planar region, I'm talking about a very important concept which is nothing but called as the congruent figures. So what are congruent figures? What is the meaning of congruent figures? So as we know that congruent figures are those figures if they have the same shape and the same size. For an instance, again, I'm talking about the triangular field of Mahiti, in which he divided the triangular field into the three equal portions, and those three equal portions, if they are equal in area, we can say that they are actually called as congruent if they have the same shape and they have the same size. If they have the same shape and they have the same size. Furthermore, we can say that, let us suppose if I just have these two quadrilaterals, so we can say that these two quadrilaterals are congruent because they definitely have the same shape and they have the same size. And further, we can say that the two figures are congruent, then they have equal area. So this is really an important concept. If the two figures are congruent, then they have the equal areas. So if the portions of the triangular field of Mahiti, they were congruent, then they definitely should have the equal areas. But if I'm just talking about the converse of this particular statement, means if I'm saying that the portions are equal in areas, then either they are congruent or not. So the answer is no. So this is a very special important note which says that the converse of this statement is not true. That is, two figures having the equal areas need not to be congruent. For an instance, if if we'll take any particular two squares having the same areas, we cannot say that they are congruent to each other. So always remember, whenever we are just talking about the congruent figures, then congruent figures are those figures, those do have the same shape and the same size. As you can see, these two quadrilaterals have the same shape and the same size, and furthermore, if they are congruent, then they must have equal areas. They must have equal areas, but the converse of this statement is not true at all. Now let us suppose, again, if I'm just talking about any particular figure which is nothing but formed by the combination of two non-overlapping figures. What is the meaning of it? Let us suppose if I'm just talking about such kind of figure. So as you can see, if I'm just talking about the whole figure T, so it is nothing but a combination of two non-overlapping figures, a figure P and a figure Q. So if I just wanted to find out the area of such a kind of figure, then I can say that the area of the total figure T can be calculated if we'll calculate the area of the P figure plus the area of the Q figure. So in order to find the area of such type of figures, we always use the concept of area of the figure T should be is equal to the area of the figure P plus the area of the figure Q. So this is nothing but the way through which we can able to find out the area of any particular figure which do have a non-overlapping portion. As you can see, they have the non-overlapping portion. They are not congruent to each other, means P and Q, they are not congruent to each other. So in order to find out the area of such kind of a combination, we always use this particular concept. Furthermore, if I'm just talking about in whole concept, then we can say that the area of figure is actually a number in some units, means in centimeter square, in meter square. It is a number. For an instance, if I'm talking about the area of the square as 25 centimeter square, so 25 is nothing but a number. So area of the figure is nothing but a number in some units which is associated with the part of the plane which is enclosed by the figure with the two properties. So there are two properties that are related with it. First of all, if A and B are two congruent figures, if we have A and B are two congruent figures, then area of A should always be equal to area of B. Always remember, we always write the area as nothing but ARA. As you can see over here, area is represented by AR, and within A, we have A is nothing but a congruent figure which we have taken as A. And furthermore, if I'm just talking about area of B, so area of B is nothing but just same as that of area of A if we have two congruent figures. So always remember, whenever we have the two congruent figures, then their area should be equal to each other. So if I'll just take an example of the Mahiti farmer again, so it means that if all the three parts of his triangular field are congruent, then definitely their area should be equal. So through this particular concept, we can also say that he just divided the triangular field into an equal portions. So furthermore, and we can say that about the second part, if a planar region which is formed by a figure T, so here we are just talking about the previous figure that we have taken, means a T figure which is nothing but a combination of two non-overlapping figures. So here we are just saying that a planar region formed by a figure T is made up of two non-overlapping planar region which is formed by the figure P and the figure Q, and then we can write the area of the T is nothing but is equal to area of P plus area of Q. So this is all about related with the concept of the area of the congruent figures or area of the two non-overlapping figures, which can be written in the formation of area of T should be equal to area of P plus area of Q. So what we are now going to do in this particular chapter, first of all, we already are aware about how to find the area of the plane figures. For an instance, I'm talking about square, rectangle, parallelogram, trapezium. We all already know about all this concept through which we can able to find out the area of such type of figure. So what are we going to do in this particular chapter? In this chapter, we will use that knowledge of our finding the area of the plane figures, and using that knowledge, we will try to develop a relationship, or we will see the relationship that do exist between the geometrical figures under the certain conditions. For an instance, if they will be on the same base and between the same parallels, and there are some conditions which are related with their areas, and many more such important conditions we will going to study in this particular chapter. So let's just start with the very first concept, that is nothing but figures that are on the same base and between the same parallels. So let's just see the very first topic.